Welcome to a new session on Essentials of Material Logic, Observation and Experiment. Induction may be defined as the operation of discovering and proving general propositions. It is true that the process of indirectly ascertaining individual facts is as truly inductive as that by which we establish general truths. But it is not a different kind of induction. It is a form of the very same process. Since on the one hand generals are but collections of particulars definite in kind, but indefinite in number, and on the other hand whenever the evidence which we derive from observation of known cases justifies us in drawing an inference respecting even one unknown case, we should on the same evidence be justified in drawing a similar inference with respect to a whole class of cases. The inference either does not hold at all, or it holds in all cases of a certain description, in all cases which in certain definable respects resemble those we have observed. If these remarks are just, if the principles and rules of inference are the same, whether we infer general propositions or individual facts, it follows that a complete logic of the sciences would be also a complete logic of practical business and common life. Since there is no case of legitimate inference from experience in which the conclusion may not legitimately be a general proposition, an analysis of the process by which general truths are arrived at is virtually an analysis of all induction whatever. Whether we are inquiring into a scientific principle or into an individual fact, and whether we proceed by experiment or ratiocination, every step in the train of inferences is essentially inductive, and the legitimacy of the induction depends in both cases on the same conditions. If the identity of the logical processes which prove particular facts and those which establish general scientific truths required any additional confirmation, it would be sufficient to consider that in many branches of science single facts and principles have to be proved. The facts as completely individual as any that are debated in a court of justice, but which are proved in the same manner as the other truths of the science and without disturbing in any degree the homogeneity of its method. A remarkable example of this is afforded by astronomy. The individual facts on which that science grounds its most important deductions, such facts as the magnitudes of the bodies of the solar system, their distances from one another, the figure of the earth and its rotation, are scarcely any of them accessible to our means of direct observation. They are proved indirectly by the aid of inductions founded on other facts which we can reach easily. Induction is the process of establishing universal law from particular facts. This means that induction must first begin with collection of particular facts. Collection of facts is made possible through the process of observation and experiment. Since they supply the facts or the materials for inductive reasoning, they are described as the material grounds of induction. At every stage of inductive reasoning, facts are essential. Hence, observation plays an active role throughout the inductive process. Observation and description are an essential part of scientific inquiry. Observation is the first stage of scientific induction. It sets us on the search for a universal law governing it. Observation, thus, is the active, selective and systematic process of collecting facts. Experiment is another method of collecting facts. Some important characteristics of experiment include control over conditions, repetition, operational definition of terms, deliberate observation, artificial situation, etc. Observation. Etymologically, the term observation means keeping an object before the mind. In scientific inquiry, observation means the selective perception of facts with a definite purpose. So, observation differs from perception. Observation is an active process whereas ordinary perception is a passive process. Observation is a process of looking at things with the purpose of determining their nature as accurately as possible. It is the deliberate or active perception of a phenomenon. Facts obtained by observation provide the hard core for the development of hypothesis. But mere observation and description do not satisfy the usual standards expected of scientific inquiry, but they provide a basis for confirming or invalidating hypotheses. It is not a pure sense activity or passive reception of facts through the senses. Observation is regulated perception of facts presented by nature. For instance, we observe eclipses, comets and so on. Observation can be defined as the objective, selective, systematic and concentrated activity of mind performed through the senses. Observation and description in science should have some expected standards of objectivity, completeness and accuracy. These standards are to be interpreted in the context of the nature of scientific inquiry. Objectivity means the observation and description in which other qualified observers in similar circumstances can experience and describe. Completeness involves thoroughness in observing, reporting and relating relevant data. Accuracy requires that observations and descriptions be sufficiently precise and exact in the given conditions under which they are conducted and the requirements set for the confirmation of the hypothesis. Characteristics of scientific observation. 1. Observation is selective. In observation, we must select only those facts which are connected with the purpose. For instance, an artist and a botanist see a flower differently. 2. Observation is teleological. Observation involves a definite goal or purpose. In observation, we perceive things with a definite purpose. 3. Observation is unbiased. In observation, for correct information of facts, we should observe things without any bias or prejudice. Fallacies of observation. In the process of observation, there are many difficulties that may lead to certain errors or fallacies. The possible errors are non-observation and mal-observation. 1. The fallacy of non-observation. Non-observation means the failure to observe some conditions or factors which are actually necessary for the analysis. So, non-observation is a negative fallacy or it is a fallacy of omission. This fallacy arises either due to the complexity of the observed phenomenon or due to the prejudices on the part of the observer. The fallacy of non-observation can be divided into two. 1. Non-observation of instances and 2. Non-observation of essential circumstances. The former consists of overlooking or omitting relevant instances or facts of the phenomenon under observation. This can be due to the bias or unfavorable physical conditions. The latter consists of focusing on unnecessary circumstances by neglecting the relevant circumstances. For example, the popular beliefs like the dreams of early morning will become true and the number 13 will always bring misfortune are cases of generalizations based on non-observation. Similarly, the conclusions like the good are invariably happy and the wicked are unhappy and fortune favors fools, etc. are also based on insufficient observation of instances. 2. The fallacy of malobservation. Malobservation occurs due to the wrong interpretation of the observed facts. Hence, what is perceived is misunderstood. It involves wrong or mistaken observation and sometimes wrong explanation also. So, it is a positive fallacy or a fallacy of commission. It consists of mistaking one thing for another. All kinds of illusions and hallucinations are examples of malobservation. Malobservation may arise due to defective sense perception or mental attitude of the observer. The fallacy of malobservation arises due to the wrong interpretation of what is observed. For example, the rope snake illusion in dim light is a common instance of a malobservation. experiment. Experiment is another method of collecting and analyzing facts. It is observation under controlled conditions. Experiment is the process of collecting facts by using artificial equipments and by altering conditions at will. In observation, we are at the mercy of the nature, but in experiment, the phenomenon is under our control and we produce it as and when we require. Observation is selective perception of natural facts under the given conditions, whereas experiment is based on the artificial reproduction of conditions by man. Experiment is conducted in artificial conditions and by using artificial equipments. The phenomenon is made for each experiment. The conditions are always under the control. Since variation and alteration of circumstances are possible, rapid advance in scientific knowledge is possible. More precision and accuracy leading to trustworthy results are found. It always proceeds from cause to effect only. Characteristics of experiment. 1. Experiment is deliberate observation. In experiment, we examine phenomena according to the terms we prescribe. It is deliberately designed to find out the answers to definite questions. 2. Experiment involves variation of conditions. Events and phenomena presented to us by nature are very complex. They are accompanied by many conditions. The scientist has to eliminate irrelevant conditions that obstruct observation. In experiment, the scientist can vary the conditions at will and determine which of them are relevant and which are irrelevant. 3. Experiment involves repetition. Another characteristic of experiment is repetition. The conditions required for the experiment are under full control of the experimenter. Hence, he can repeat the different stages of experiment as required. Moreover, others can also repeat the experiment in similar conditions. Advantages of experiment over observation. 1. Control over the phenomenon. In experiment, the experimenter has full control over the phenomenon. Hence, he can repeat the different stages of experiment until he gets satisfactory results. 2. Separation of various factors. Nature presents the phenomenon in complex surroundings. The experimenter can isolate the necessary factors for observation. Hence, experiment helps one to concentrate on the relevant and necessary factors of the phenomenon. 3. Variation of conditions. In experiment, one can alter the conditions at will and observe the changes that are taking place in the phenomenon. Quantitative changes can be brought about in experiment, but it is not possible in observation. 4. Accuracy of knowledge. Experiment can provide more accurate knowledge of a phenomenon than simple observation. In experiment, one can observe and examine the phenomenon with greater precision and accuracy. This is possible because in experiment, one has full control over the phenomenon. Advantages of observation over experiment. 1. Observation is wider in scope. There are realms of reality which are beyond the scope of experiment. In such circumstances, one has to depend completely on observation. 2. Observation prepares the way for experiment. Observation is prior to experiment. The scientist can conduct an experimentally after collecting sufficient data through observation. 3. In observation, one can proceed from cause to effect and also from effect to cause. Observation always proceeds from cause to effect and is also possible from effect to cause, but in experiment, one can proceed only from cause to effect. 4. The phenomenon under observation has originality. The phenomenon artificially produced in experiment is not always the same as the phenomena that we get in observation. In experiment, the scientist artificially sets up the necessary conditions, but in observation, the scientist is dealing with original natural phenomenon. The first and most obvious distinction between observation and experiment is that The latter is an immense extension of the former. It not only enables us to produce a much greater number of variations in the circumstances than nature spontaneously offers, but also in thousands of cases to produce the precise sort of variation which we are in want for discovering the law of the phenomenon. For example, in order to ascertain what principle in the atmosphere enables it to sustain life, the variation we require is that a living animal should be immersed in each component element of the atmosphere separately. But nature does not supply either oxygen or azote in a separate state. We are indebted to artificial experiment for our knowledge that it is the former and not the latter which supports respiration, and for our knowledge of the very existence of the two ingredients. The advantage of experimentation over simple observation is universally recognized. All are aware that it enables us to obtain innumerable combinations of circumstances which are not to be found in nature, and so add to nature's experiments a multitude of experiments of our own. But there is another superiority of instances artificially obtained over spontaneous instances of our own experiments over even the same experiments when made by nature, which is not of less importance and which is far from being felt and acknowledged in the same degree. When we can produce a phenomenon artificially, we can take it as it were home with us and observe it in the midst of circumstances with which in all other respects we are accurately acquainted. If we desire to know what are the effects of cause A and are able to produce A by means at our disposal, we can generally determine at our own discretion so far as is compatible with the nature of the phenomenon A, the whole of the circumstances which shall be present along with it, and thus knowing exactly the simultaneous state of everything else which is within the reach of A's influence, we have only to observe what alteration is made in that state by the presence of A. Instead of being able to choose what the concomitant circumstances shall be, we now have to discover what they are, which when we go beyond the simplest and most accessible cases, it is next to impossible to do with any precision and completeness. Let us take as an exemplification of a phenomenon which we have no means of fabricating artificially, a human mind. Nature produces many, but the consequence of our not being able to produce them by art is that in every instance in which we see a human mind developing itself or acting upon other things, we see it surrounded and obscured by an indefinite multitude of unascertainable circumstances, rendering the use of the common experimental methods almost delusive. We may conceive to what extent this is true if we consider, among other things, that whenever nature produces a human mind, she produces, in close connection with it, a body. That is, a vast complication of physical facts in no two cases perhaps exactly similar, and most of which, except the mere structure which we can examine in a sort of coarse way after it has ceased to act, are radically out of the reach of our means of exploration. If instead of a human mind, we suppose a subject of investigation to be a human society or state, all the same difficulties recur in a greatly augmented degree. Inductive inquiry, having for its object to ascertain what causes are connected with what effects, we may begin the search at either end of the road which leads from the one point to the other. We may either inquire into the effects of a given cause or into the causes of a given effect. The fact that light blackens chloride of silver might have been discovered either by experiments on light, trying what effect it would produce on various substances, or by observing that portions of the chloride had repeatedly become black and inquiring into the circumstances. The effect of the Urali poison might have become known either by administering it to animals or by examining how it happened that the wounds which the Indians of Guinea inflict with their arrows prove so uniformly mortal. Now, it is manifest from the mere statement of the examples without any theoretical discussion that artificial experimentation is applicable only to the former of these modes of investigation. We can take a cause and try what it will produce, but we cannot take an effect and try what it will be produced by. We can only watch till we see what it produced or are enabled to produce it by accident. Wherever, having nothing to guide us to the cause, we are obliged to set out from the effect and to apply the rule of varying the circumstances to the consequence, not the antecedents. We are necessarily destitute of the resource of artificial experimentation. We cannot at our choice obtain consequence as we can antecedents under any set of circumstances compatible with their nature. There are no means of producing effects, but through their causes and by the supposition the causes of the effect in question are not known to us. We have therefore no expedient but to study it where it offers itself spontaneously. If nature happens to present us with instances sufficiently varied in their circumstances, and if we are able to discover either among the proximate antecedents or among some other order of antecedents something which is always found when the effect is found, however various the circumstances, and never found when it is not, we may discover by mere observation without experiment a real uniformity in nature. Now, let us summarize. This session introduces the importance of the method of observation and experiment in the process of inductive reasoning. The characteristics of observation along with its fallacies are also mentioned. The session also includes the importance of experiment and its advantages on observation. There are some assignments for you to work out. 1. Are observation and experiment complementary to each other? If so, why? 2. Bring out the merits and demerits of observation and experiment. 3. Examine observation and experiment as methods of collecting facts in scientific investigation. 4. Explain observation as a material ground of induction. Here are some books for your further reference. An Introductory Logic by Kilgore J. William, Reinhardt and Winston Publishers, London 1968. Fundamentals of Logic by Sullivan J. Daniel, McGraw-Hill Book Company, New York 1963. An Introduction to Logic and Scientific Method, Cohen R. Morris and Ernest Nagel, Allied Publishers, New Delhi 1976. Introduction to Logic by Copy M. Irwin, Macmillan, New York 1982. A Textbook of Logic, SCRT, Thiruvananthapuram 2003. Thank you for watching this session. We will meet again with another topic. Till then, bye.